orbitals S and P. Whenever you see S and P, it means that the element belongs to the block S, P. It means that the element belongs to the block P. How do you calculate, how do you determine each group? It is very easy. You have to calculate all the number of all the electrons on S and P. In this case, we have 3 electrons, 2 on S and 1 on P. 2 plus 1 makes 3. They make 3, which means it is the group 3A. It is very easy. 3s2, 3p1, 2 plus 1, 3. It means it is the group 3. Because it is S and P, it belongs to the block P. It is a group A. Only from B groups. Okay? Do you understand? Seulement les éléments métalliques de ce qu'on appelle les métaux de transition qui appartiennent donc au bloc D, seuls les éléments qui appartiennent au bloc D sont de groupe B. Okay? Okay? Guys, are you following?
Yes, ma'am.
Okay. Yes. Now, what about the elements that belong in D, en effet? What about those that belong to the block D? What do we find in the valence shell? We will find in the valence shell both orbitals D and S. We will find in the valence shell both orbitals D and S. Okay? Listen to me and follow, please. Look at the Klitschkowski rule or chart. Look at the Klitschkowski rule or chart. 1s, 2s, 2p, 3s, 3p, 4s, and 3d. Did you notice that the 4s comes before the 3d? Yes?
Yes.
You have to fill the 4s with electrons. Before filling, vous devez remplir la S avec des électrons. You have to fill the 4s with electrons before the 3d. If you have if an element has an electron configuration or like this, the one I'm going to read, si un élément à la configuration électronique, je vais vous lire 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2, for example. 4s2, 3d2. You wrote the electron configuration, which is correct. You started with 4s2 before the 3d. But be careful, guys. Whenever the 4s contains electrons and the 3d also contains electrons, the stability will change. In this case, before having electrons, for the 4s is more stable than the 3d or less stable? In the case of the Klitschkowski rule without electrons, is the 4s more stable than the 3d or less stable?
Less.
It is less stable or more stable? 4s and the 3d.
More stable.
More stable.
It is, sorry.
More stable than.
Yes, it is more stable. Yes, thank you, Shaban. And who else told me more stable? It was a girl's voice. Who told me? It is more stable?
Me.
Okay, never mind. Yes, thank you. Okay, it is more stable. 4s is more stable than 3 with it. Because the 4s is more stable than the 3d when they are empty, parce qu'elles sont vides, la 4s est plus stable que la 3d quand elles sont vides. We start by 4s. We start by filling the 4s. On commence par remplir la 4s. Okay? But whenever they contain electrons, the stability will change and the 3d will become more stable than the 4s. Quand vous mettez des électrons, la stabilité va changer et la 3d va venir avant la 4s. C'est très facile. Vous utilisez la règle de Klitschkowski et vous remplissez la 4s avant la 3d. Je vous ai donné un exemple, la 4s2, la 3d2. Maintenant, une fois qu'elle contient les électrons, vous avez écrit la configuration électronique, vous devez les replacer dans l'ordre. Au lieu de mettre, instead, or when you wrote the electron configuration, based on the chart, on the Klitschkowski chart rule. You started with 4s before 3d, well done, it is correct. But now that the 4s contains 2 electrons, and for example, the 3d contains 2 electrons, in this case, you have to write it again with 3d 2 before 4s2. Because in this case, when they contain electron, the stability changes. And 3d2 comes before s2. And actually, we have the proof of that. Nous avons la preuve que la 4s est moins stable quand elle contient des électrons. What is this proof? What is this proof? Actually, it is the proof with the transition metals, copper, for example. Do you know that copper has a valence shell electron configuration of, if you follow Klitschkovsky rule, you will have 4s2, 3d, 9, 3d 9, exactly. 4s2, 3d 9. And you know that instead of leaving 3d9, this is not as stable as 3d10. Thank you. For S1, 3d10 because it's more stable. For S1, 3d10, but in this case, the orbitals contain electrons. They are not empty anymore. Elles contiennent des électrons, donc elles ne sont pas vides. In this case, I have to write the electron to reorder them. Je dois les réorganiser en écrivant by writing 3d10 for S1. I just reordered them. Je les ai réorganisés. C'est tout. Au lieu de mettre 4s1, 3d10, je réécris 3d10, 4s1. Actually, we have the proof of that because this is the electron configuration of copper 0 in its metallic state, dans son état métallique, le cuivre 0. But be careful. When we have copper 1, you know which electron is taken? Vous savez quel électron est pris? Quel électron est enlevé? Which electron is taken? Quel électron? Is it the electron from the 4s1 or is it the electron from the 3d10? Write with me on your copybooks in order to follow. Actually, the electron that is taken is the one from the 4s1. Copper 1 has an electron configuration of the valence shell 3d10 only, 3d10. And if we have copper 2, it is 3d9. And actually, in coordination chemistry, copper 2 is called, en chimie de coordination, le cuivre 2 est appelé un D9. Un D9, it means that the electron configuration finishes with D9. We say in our books, even in our books, même dans nos livres de chimie de coordination, we say copper 2 is a D9 ion. C'est un D9, un ion D9. Copper 1 is a D10 ion. Okay, this is the proof that the less stable orbital is the S, not the D. Do you think that the electrons that are taken during oxidation, ionization, les électrons qui sont enlevés durant l'oxydation, l'ionisation, c'est n'importe quel électron? Any electrons can be taken during ionization or oxidation? Any electron? Not at all. We don't take the core electrons. On n'enlève pas les électrons de cœur. We don't take the core electrons. We take the valence electrons, the last ones. On enlève les plus externes, les derniers. We don't take the core electrons. On prend pas les électrons de cœur. I told you last time. I'm gonna write it again. We say core electrons, les électrons de cœur. Core electrons in French, électrons de cœur, they are the closest to the nucleus. They are the closest, c'est les plus proches du noyau. What does it mean? It means that the attraction is very strong. Ça signifie que l'attraction est très forte. C'est des électrons qui sont stables, qui sont retenus par le noyau. Those electrons are stable because they are strongly attracted by the nucleus or attracted to the nucleus. Okay? And we have the valence electrons. The valence electrons, which are the external electrons. They are the valence electrons, les électrons de valence. Les électrons de valence, c'est les électrons externes. Et c'est les électrons impliqués dans les réactions chimiques, dans l'oxydation, dans les réactions chimiques. The valence electrons are the external electrons and they are the ones involved in the chemical reactions. Okay? Do you understand? That's why I told you the proof that the 4s is the less stable is that its electron is the one taken during oxidation. La preuve que la 4s est la moins stable, c'est parce que c'est son électron et pas celui de la 3D qui est enlevé durant l'oxydation. Do you understand? I think that your teachers last year did not tell you about this because this is really a discipline that is studied by coordination chemists or inorganic chemists only. C'est une discipline qui est étudiée par les chimistes, les inorganiciens ou les chimistes de coordination. Okay, guys, did you understand?
Yes.
Yeah.
Yes.
Are very important information, very basic but important informations of general chemistry. The question asked us, write its electron configuration. Done. We have done that. Check whether, vérifier si. Check whether, vérifier si. Whether c'est if. Check whether it really belongs to the group 13. Let's go back to the electron configuration. We said it is the group 3A. And actually the group 3A is the group, what we call the group 13 in English. 3A or 13 in English. There is no problem because if you have the group 4A, in English it will be the group, if aluminium belongs to the group 3A, and the group 13 in English. The element that comes, the elements that come after aluminium will belong to the group 4A. And in English, it will be the group
14.
14. And 5A will be 15, and so on. Okay? And so on, etc. Retenez, Bark, 3A, c'est 13. Vous allez avoir les autres. OK? Give me a minute, guys, sorry. Hello. I hope you understood what we've been studying because it's important. Okay, to what period does it belong? Almost finished, guys, don't worry. To what period does it belong? À quelle période il appartient? Done, we have done that. From the fact box, guys, from the fact box, do you think that aluminium is heavy? À partir du tableau récapitulatif qu'on appelle the fact. Do you think that aluminium is heavy? In order to answer, let's see the fact box again. Look at the relative atomic mass. Look at the atomic mass. It is about, c'est à peu près, it is about 27 grams per mole. It is about 27 grams. It is about 27 grams per mole. Do you think it is heavy? In order to know whether it's heavy, let's go back to the periodic table. Let's go back to the periodic table. Look at the other metals. Regardez les autres métaux. Look at the other metals like zinc, for example. Zinc, 1 mole of zinc weights. Do you see zinc? It is a transition metal. It is the last transition metal. It is the last group of the transition metals. Zinc. Do you Zn? Do you see zinc?
Yes.
Do you see zinc? Est-ce que vous voyez le zinc?
Yes,
Okay.
yes, yes.
What is the atomic mass of zinc? What is the atomic mass of zinc? Look.
13.
Really? The atomic mass is 30? Really?
65.38.
65.39.
Yes, it is about 65. The atomic mass is 65, which means that 1 mole of zinc pesa, the mass of 1 mole of zinc is 65 grams. 1 mole is in grams. Be careful because it's heavy. C'est lourd, une mole, mais comme un atome, not like an atom. It is 65 grams. Look at gallium, which is a metal from the block P. It is 69. Look at indium. It is 100, almost. It is about 115. Look at mercury, 200. Look at copper, 63. Look at germanium, 72. And aluminium is 27. It is extremely light. C'est vraiment léger. 1 mole. The number of Avogadro atoms of aluminium. 1 mole of aluminium pèse seulement 27 grams. You will tell me, but madam, Madam, there are other elements that are lighter. Il y a d'autres éléments qui sont plus légers. For example, carbon is 12, only 12, and beryllium is only 9. But be careful. Aluminium is a metal. It is not like carbon. Carbon and boron are lighter, okay, but they are not metals. In the case of aluminium, we have very interesting properties because it is a metal and it is light at the same time. Il a des propriétés très intéressantes. C'est un métal et il est très léger. Okay? Last question. What is the meaning of melting and boiling points? Maybe, well, we can finish this. It is very light. What is the meaning of melting and boiling points? The melting point, c'est le point de... What is the... To melt. Quel est le signe de la signification du verbe to melt? To melt.
From the solid to liquid.
Fuser. C'est faire une fusion. حاجة qui دوب. Quelque chose qui fond. To melt. To melt. C'est quelque chose qui fond. حاجة دوب. Melting, c'est quelque chose qui fond. En science, on dit fuser. Faire une fusion. Fuser. OK? To melt, c'est fuser ou fondre. The melting point, c'est le point de fusion. The boiling point, c'est le point ou la température d'ébullition. Okay? The melting point is the temperature at which the solid becomes liquid only. The melting point is the temperature at which the solid becomes liquid. Le solide devient liquide, ça veut dire qu'il fuse, il fait une fusion. We say that the solid melts. The solid melts at the melting point. Okay? The solid becomes liquid. What about the boiling point? The boiling point is the temperature at which the liquid turns to vapor. The liquid se transforme en vapeur. We can say the liquid turns to vapor, or we can say the liquid turns to a gas. In French, it's correct. Un gaz ou une vapeur. La vapeur ou le gaz. Vapor or gas. Okay? Do you understand?
Yes.
Did you understand, guys? On the left side of the slide, you can see some ice melting. On the left side of the slide, à gauche de la diapo, vous pouvez voir de la glace qui fond. On the left side of the slide, you can see the melting of ice. On the right side, this is just a picture to show you some boiling phenomenon d'ébullition. Okay? Give me a minute, I'm going to take your names. Thank you very much for being here. Thank you very much for listening. I hope you enjoyed the lesson and understood what I said. Who has a question for me before leaving? Who has a question?
It's clear, madam. Thanks.
You're welcome, no problem.